All right, hello, welcome back. This is video number 5 in my series of tutorials on how to program the FPGA on the DE10 Nano. Today I wanted to cover what is a decoder, and we'll go ahead and implement a small one on the DE10 Nano. And then in the following video, I will be covering how to actually use this for things like implementing a 7-segment display. So with that said, let's go ahead and dive right in. I'm going to create a new project. Click Next. We will change the project directory. I'm going to go to my DE10 Nano Live Demos folder. Live Demos, vid5, select. And this is going to be a 2-bit decoder. Hi everyone, this is Cameron. I just wanted to give a quick announcement. Please do not name your project with a number like the number 2. Instead, you should actually just type out or spell the number instead. This actually will cause some problems for you later down the road, and that happens to me in this video. So to save you the trouble, just make sure you use a name that does not start with a number. Okay, thank you. Back to the video. Next. And next. Next. Devices, SE base. I feel like I'm getting better at this. It's the 23U7. 23i7. U23i7. That's the one. We'll click Next, Next, Finish. All right, we'll give that a second to load. Ooh, not responding, huh? Okay, so. Oh my goodness, please recover. There it goes. Okay, I knew you could do it. All right, so let me just pop over to Excel for a second and let's talk about what a decoder is. So we're going to do a simple 2-bit decoder. So our inputs, let's do this. Inputs, we're going to have 2 inputs. Merge and center. Merge in center. How come I can never find that? There it is. And then we have outputs. And we are going to have 4 outputs. There it is. All right, our inputs will be A and B. And our outputs are going to be Y0, Y1, Y2, and Y3. Okay, and what a decoder does, oops, I hit page down, is we are going to have all possible combinations of inputs. And what a decoder does is it simply echoes out a unique value. You can call this one-hot encoding, I believe, for each of these. So I'm just drawing out the truth table for a decoder. So something like that. So let's give this guy thick outside border and all borders. That did not work. And all borders. Okay, so this equation here can be thought of as A naught, B naught. All right, and then this is A naught, B, and this is A B naught, and this is A B. So, oops, not A B naught. So if you recall from our last video, you'll notice these are minterms. It's just things that are going to be ANDed together. All right, and what we're doing is that we're encoding those minterms. And that's going to be a decoder. So this is pretty much the concept. This is what we have to implement. And these are the equations. So y0 is going to follow this equation, and y1. So like the way you handle doing the k-map for multiple outputs is you just handle them one at a time. So you'll do a k-map for this guy, a k-map for this guy, k-map for this guy, and a k-map for this guy, and you'll come up with multiple logic equations, all right? So you'll get a logic equation for y0, you'll get a logic equation for y1, and for y2, and that is a, you know, in my previous video I mentioned that you can have multiple outputs. That's how you're going to do it. You're going to take just this first column and you handle the case where you have just this first column. You'll do the k-map, you'll get the equation, and you now have to implement the logic just for that first output, and then you repeat the process for all the outputs. So hopefully that makes sense. But this particular example is simple enough that we don't have to do the k-map. We can just see that y0 is going to be true when we have a naught, b naught, and then it'll be off for all the other cases. So really, these are the equations for each of the outputs. Now, this is useful because what you can do is you can easily come up with a way of deriving any sort of equation from these minterms. This is all possible combination of minterms from your inputs, and that's going to allow you to basically, like in the case of the 7 segment, which we'll see in the next video, it makes it easier to implement the 7 segment display. You can also use the decoder for many other applications, whatever you might want to be using it for. So I'm not going to really spend too much time diving into this. This is a pretty simple example. So let's dive right in and implement this decoder. And yeah. So I'm thinking we'll do y0 on one LED, y1 on another LED, y2 on another LED, and y3 on another LED. And then we'll do A, B on switches. Easy peasy. So again, yeah, pretty simple, not as complicated as the k-maps. So let's just go ahead and implement this. We are going to be doing this on a block diagram. So here I am in Quartus Prime. I'm going to do File, New, and I will get my block diagram schematic file. And we will go ahead and get out our, well, before we do that, let's get our inputs. Great. Let's get our outputs. Great. And let's get our AND gates, right? Because we need AND gates. If we take a look back at this Excel sheet, A and B, or yeah, A and B, A and not B. These are all AND gates. So we just need AND gates to implement this. And 2. And we actually basically need 1 for each output. 1, 2, 3, 4. Great. Awesome. Doing great. There you go. Let's give our gates, our outputs names. So this will be y0. This will be, oops, cancel. Control Z, Control Z. Let me zoom in on this and go back to the select tool. Oh, we're still going to do it that way. Okay. Y1, Y2, and Y3. Let's go ahead and get our select tool and we will draw our wires. Oops. Again, this video is going to be pretty simple to look at, and the value of something like this might be lost on you at first, but I'm telling you, there's going to be very clear applications. Oops, I clicked help on accident. In the following video and maybe even future videos as well. But really simple concept, very powerful applications. Okay, so if I remember correctly, we need a NOT gate, Oh, I should probably show you how I got that. So I clicked on this. This window popped up. I typed in not, and there it is. So we need a not here and here, and one for this one for this one, and no more. Great. Let's zoom in some more. And as you might be able to tell, working with these block diagrams are really not going to be very, efficient as your designs start getting bigger and bigger. So ultimately, we do want to move to Verilog, and that will be coming in the later tutorials. This is more so that if you're just starting out with Verilog, you really have that visual picture, drilled into you about like what it is that we're programming. So that's why I'm deciding to start out with the block diagrams. All right, so these guys are looking good. So not A and not B. Next up we have A and not B. And lastly, next we have not A and B. And last but not least, we have B and we have A. Great. And that is our whole design. Zoom out a little here. There you go. That's our whole design. So let's go ahead and do our analysis and synthesis. Save that block diagram. We'll save that 2-bit decoder. While this is loading, I just want to point out one thing that's interesting, an interesting property. So if you do a little research on this topic, obviously you can scale this up, right? So we can add 3 inputs and then the number of outputs we have will increase. And there is an equation that models that property. So if you have n inputs, you're going to have 2 raised to the n power outputs. All right, so inputs and outputs. So this thing starts to scale and scale and scale. So that's something to keep in mind. Okay, so we're done. Let's do the waveform. So I'm going to do new, and we will do the university program vector waveform. Let's right click on the blank space, insert node or bus, node finder, list all of them, bring them all in, click OK, click OK. And on A, we're going to apply the counter value. Every 100 nanoseconds should be good. And for B, we're going to apply the counter value. Every 200 nanoseconds should be good. And let's hit the play button for functional, save it. Save that waveform. It's going to generate a test bench for us. Oh, we got an error. How did we get an error? Got a syntax error. What happened? This thing failed? How could it fail? Do we need to do the pin assignments? Oh, I think we have to compile. Do we have to compile? Start. Let's just compile the whole thing. I'm going to pause the recording and we'll come back when this is done. Okay, we're back. I think it's complaining because I started my top level entity with a 2. And I am really not interested in renaming that. That'll take too much time. Let me pause the video, rename it, and see if that fixes it. So stand by 1 second. Okay, we are back. I just repeated everything I've done so far in this video, except this time I have named my project TWO bit decoder. So lesson learned, do not start your project names and your top level entities or any of your modules with a number if you want to use the vector waveform. It's not that it's invalid syntax. I think the problem is that this vector waveform simulation thing is generating the test bench for you, and because it's generating code, there's a bug, and when it reads your 2 at the start of your module entity name, it thinks that it's the start of a line of code instead of a name or something. I don't even know, but it worked now. Now that I got rid of the literal 2 and spelled out 2, everything's looking good. So when we have A and B off, let me get my Excel sheet up. We can verify. I mean, this design is so simple, we can already pretty much tell that it's good to go. A and B off, we have Y0, good to go. Y1 is the next one. Y2, Y3. Yeah, we're good. This is all looking correct. Awesome. So we can go ahead and close out of this. And I'm just going to keep working out of this one, just so you know, like if I go over to the diagram, it looks a little different. I got a little impatient. I have all lowercase stuff, but this is the same schematic as what I had just a moment ago. So don't even worry about that. I already compiled. I have check marks next to everything. So we are now ready for the pin assignment. And for this one, we need to get the schematic file opened up. So if I can just get File Explorer to open, there we go. And I think I have mine in here. And schematic. DE10 nano schematic. So the reason why I'm opening up the schematic file is I need to get the pin codes for the pin assignments, because what we are going to be doing next is we're going to assignments and we're going to pin planner, and we need to basically assign the pins of our inputs and outputs to the LEDs and the switches. So here are our inputs and outputs, and we need to assign a location. So let me bring this PDF to the other screen. There we go, and we're looking for SW0. There's the LEDs. Let's do the LEDs first. So LED 0 is W15. Oh, let me zoom in on that so it's clear in the video. Oh, yeah. LED 0 is W15. 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 Cool. And we'll switch that to the 3.3 LVTTL. Next up is LED 1, which is AA24. AA24. Enter. And we'll switch that to the 3.3 LVTTL. A2 will be LED2, which is V16. V16. 3.3 volt. Great. Whoops. Okay. Come on, really? And what is this guy? Can we delete this? Yeah, I'm just messing up all over the place today. All right, Y2. LED 2 is V16. And LED 3 is V15. V15. And we want that to be the 3.3 volt LVLLT. There we go. Now we just have to do our switches. Page down, page down, page down, page down, page down. Where are they? I think I passed it. I'm going back. There they are. Page 6, zoom in on that. All right. So we'll do switch 0, Y24, and switch 1, W24. Once again, 3.3 LVLLT. Great. And we can close that. And we can close the schematic, and we're good to go. Let's go ahead and do our compile. Start compilation. I'm going to pause it. Actually, while that is compiling, instead of pausing it, let's switch over to the tabletop view. And as you can see, I have a better camera now for my tabletop view. And we're going to go ahead and give this guy power. And plug in the USB cable that is on the same side as the power. All right. And we're still compiling, so now we'll go on pause. Okay, we are all done compiling. So now we'll go up to Tools, and we'll go to Programmer. Make sure that DESOC is selected as the hardware. We'll click Auto Detect and leave this default. Say yes. And then for the 5CSEBA6, we'll click on the file. Double click on None, go to Output Files, get this SOF, click Open. Check the box for Program/Configure and click Start. Okay, it says Success. Let's switch over to the tabletop. And we can see that if we flip them all down, let's see here. All right, so that looks correct to me. So basically what we have here is we basically have a binary counter. So let me see if I can get this closer to the camera. So right now we have all the switches off. Right, all the switches are down. And we are on this rightmost LED all the way at the top. If I flip up this first one, now we move to the left one LED. And then if I flip up only the second one, then we move from the right to the left 2 spaces. And if I flip them all up, we go all the way. Well, we move 4 spaces to the left. And yeah, that's our decoder. All right, so that is going to do it for this video. Thank you so much for tuning in and following along. Appreciate the support. Like, comment, and subscribe. And I'll see you in the next one where we're going to actually see how we can use this concept of a decoder to implement something like a 7-segment display. Yeah, thank you for watching. If you haven't noticed, and I'll just go ahead and mention this now. If you haven't noticed, the DE10 Nano does not have a built-in 7-segment display. So what I do recommend getting is a 7-segment display with a breadboard, if you don't already have these. And I think we're gonna need some jumper wire. So some jumper wire like this to wire this up. And I believe we're gonna need some resistors as well. So if you don't have these sort of components, I recommend getting these off of Amazon. So let's see here. Let's just take a quick little detour to Amazon. Amazon. These are all pretty cheap components. All right. 7-seg display. Wow. There you go. These guys. Get the individual ones. Look for the cheapest one you can get. Yeah. And then the other thing you will need, jumper wire. And we need the male to male. So yeah, any of these will be good. Just get a male to male for sure. Yeah, lots of good options here. And you need a breadboard. All of these components are very, very cheap. Breadboard, any will do. And we're gonna need a resistor set. Resistor set, forget the exact size of the resistor. I think probably 220 ohm will work. Or 330 ohm, something like that. But yeah, get something like this for your collection. If you don't already have this stuff, all of this stuff is pretty cheap. So, great. All right, I'll see you in the next one. Thank you.